High above the swirling clouds of Saturn's North Pole, a geometric masterpiece defies everything we know about planetary weather. A perfect hexagon, large enough to engulf 4 Earths, spins with hypnotic precision, a structure so precise it feels almost artificial. For decades, scientists have marveled at this atmospheric anomaly, this 6-sided enigma that shouldn't exist according to our understanding of fluid dynamics and gas giant behavior. Yet there it remains, a permanent feature in Saturn's turbulent skies, challenging our assumptions and sparking imaginations across the globe. What could possibly create and maintain such perfect symmetry in the chaos of a planetary storm system? The answer might be more extraordinary than we ever imagined. Some researchers believe we're witnessing a natural phenomenon unlike any other in our solar system, a unique atmospheric dance driven by jet streams and planetary rotation. Others dare to ask more provocative questions. Could this be evidence of advanced technology at work? Might we be looking at some form of alien weather control device, engineered to stabilize or manipulate Saturn's atmosphere for purposes beyond our current comprehension? And then there are those who venture even further into the realm of possibility, suggesting that this geometric wonder might function as some kind of dimensional gateway or cosmic portal, a structure that bends not just weather patterns but the very fabric of space-time itself. Today, we embark on a journey to explore these compelling possibilities, to examine the evidence behind each theory, and to confront one of the most fascinating mysteries in our celestial neighborhood. We'll look at the latest scientific data from the Cassini mission, consider the mathematical precision of the hexagon structure, and explore why this feature continues to defy easy explanation. This isn't just about understanding a strange weather pattern. It's about questioning what we know about planetary formation, about intelligence in the universe, and about the very nature of reality itself. So join me as we venture into the unknown to unravel the secrets of Saturn's mysterious hexagon and discover why this cosmic puzzle might hold answers to questions we're only beginning to ask. The story of this celestial mystery begins not with modern orbiters, but with a pair of intrepid robotic explorers from a bygone era. In the early 1980s, the Voyager 1 and 2 spacecraft were racing past the ringed giant, snapping the first close-up images humanity had ever seen. It was within the grainy black and white data from Voyager 2's wide-angle camera that scientists first caught a glimpse of something utterly baffling. Nestled within Saturn's northern hemisphere, they noticed a peculiar cloud-like pattern. The images were faint, the resolution was low, and the feature was partially shrouded in the long polar night, making it easy to dismiss as a temporary atmospheric quirk or even a simple artifact of image processing. With the technology of the time and the probe's fleeting flyby nature, the true significance of that 6-sided shape was completely missed. It was filed away as a curiosity, a puzzle for another day. That day wouldn't come for over 2 decades. The mystery lay dormant, unsolved, until the arrival of a new sentinel at Saturn. The Cassini spacecraft, a marvel of modern engineering, entered orbit around the planet in 2004. Its sophisticated suite of instruments was designed to scrutinize Saturn in unparalleled detail. As the northern pole emerged from its decades-long winter into sunlight, Cassini's cameras turned toward it, and what they revealed sent shockwaves through the scientific community. There it was, not a ghostly apparition from poor data, but a stunningly crisp and persistent geometric figure. The hexagon was not only real, it was more perfect and more massive than anyone could have possibly predicted. To truly comprehend its scale, you must try to picture it. Each of the hexagon's 6 sides stretches for approximately 8,600 miles. That is a distance longer than the entire diameter of our own planet. This means you could line up 4 Earths side by side, and they would still fit comfortably within the boundaries of this colossal atmospheric structure. It is a veritable continent of weather, a monolithic jet stream of screaming winds racing at over 300 miles per hour, yet maintaining this impossibly sharp six-sided form. It's a shape you expect to see etched by a laser on a laboratory slide or drawn with a protractor on an engineer's blueprint, not churned by the chaotic forces of a gas giant's atmosphere. This precise geometry existing on such an unimaginable scale is what immediately separates it from any other weather pattern we observe in our solar system, catapulting it from a mere curiosity into a profound enigma. This staggering scale is matched only by its ferocious power and impossible longevity. The winds that scream along its six-sided boundary are a relentless force of nature, a hurricane-like jet stream moving at speeds that dwarf our most powerful terrestrial storms. At over 300 miles per hour, these winds would circumnavigate our entire planet in well under a day, a constant, violent torrent of gas. Yet despite this incredible energy, the form itself remains locked in place, a study in controlled chaos. It doesn't drift or wander like hurricanes on Earth. It is pinned to Saturn's North Pole with an unwavering stability that has now persisted across multiple generations. While Earth's weather systems are fleeting, measured in days or weeks, and even Jupiter's great red spot is slowly shrinking, Saturn's hexagon has been a permanent fixture, observed unchanged for nearly half a century since its discovery. It has outlasted every space mission sent to study it, becoming a timeless feature of the planet's identity. What makes this permanence even more baffling is how it behaves relative to Saturn's other atmospheric activity. The planet is a roiling cauldron of storms and swirling cloud bands, a dynamic and ever-changing environment. Other features shift in latitude, change color, merge, or simply fade away. But the hexagon remains an immovable anchor, a fixed geometric coordinate on a world of fluid motion. It is as if a celestial stamp has been pressed into the atmosphere, creating a permanent indentation that the chaos simply flows around, unable to erase or distort. Adding yet another layer to the mystery is its vertical structure. This isn't a two-dimensional shape painted on the cloud tops. It is a deep, multi-layered atmospheric tower. Cassini's infrared and other instruments allowed scientists to peer down through the haze, revealing that the hexagon's influence extends hundreds of kilometers deep into the atmosphere. Clouds at vastly different altitudes, each with their own density and composition, are all caught in this same six-sided dance, moving in perfect synchrony with the pattern above them. This suggests the hexagon isn't a superficial cloud formation but a profound atmospheric wave, a ripple that propagates through the very depths of Saturn's gaseous body, shaping its weather from the high clouds all the way down into the abyss. This incredible depth and cohesion point to an engine for this phenomenon that is far more powerful and deeply rooted than any surface-level weather pattern we understand. Faced with such an enduring and precise structure, scientists naturally turn to the laws of physics for an explanation, seeking to replicate this incredible phenomenon here on Earth. The leading theory revolves around a concept known as the shallow water wave model, a complex interaction between atmospheric jet streams and the powerful rotational force of the planet itself. To understand this, picture Saturn not as a solid ball, but as a deep, churning ocean of gas. The upper layer of this ocean, where we see the clouds, behaves much like water in a shallow basin. Now, imagine setting that basin on a record player spinning at tremendous speed. This rotation generates a powerful deflective force called the Coriolis effect, which causes moving fluids and gases to curve. It's the same force that shapes hurricanes on Earth, making them spiral. The theory suggests that deep within Saturn's atmosphere, a massive eastward-flowing jet stream, like a river of wind, slams into an obstacle or experiences a sudden change in velocity. This disruption sends a powerful wave rippling through the atmospheric, shallow water, much like a rock dropped in a pond. But on a rapidly spinning planet, the Coriolis effect locks this wave into a stable, standing pattern. The mathematics of fluid dynamics show that under the right conditions of wind speed and planetary rotation, this standing wave can naturally configure itself into a polygon. Remarkably, a hexagon is one of the most stable and efficient shapes that can form, creating the precise geometric pattern we observe from space. The most compelling evidence for this natural explanation comes not from computer models alone, but from tangible experiments conducted right here in laboratories. Researchers have built large cylindrical tanks, filled them with water or glycerol, and placed them on rotating tables. By controlling the speed of rotation and then stirring the fluid to simulate jet streams, they can observe how the fluid behaves. And consistently, when the conditions are just right, the chaotic swirls suddenly snap into an ordered, stable polygonal shape. They have successfully created everything from triangles and squares to pentagons, and most importantly, clear and distinct hexagons. These lab-made hexagons are not perfect, their sides might waver slightly, but they demonstrate the fundamental principle that rotating fluids can and do self-organize into geometric patterns, providing a powerful, reproducible analog for what might be happening on a planetary scale 1 billion miles away. This body of work presents an elegant and mathematically sound solution, suggesting the hexagon is a breathtaking natural spectacle, a planetary-sized testament to the beautiful and often unexpected order that can emerge from chaos. It positions the hexagon not as an anomaly, but as a key to understanding atmospheric physics on gas giants, a window into the deep workings of worlds utterly unlike our own. The sheer depth of the phenomenon revealed by Cassini actually strengthens this theory, indicating the standing wave is rooted deep in the atmosphere where these powerful forces dominate. Yet, for all its elegance, this explanation still grapples with some stubborn questions. Laboratory hexagons are fleeting, often requiring constant, precise control of conditions to maintain. Saturn's hexagon, by contrast, has displayed unwavering stability for decades, locked in place across seasons and immense atmospheric changes. The perfection of its form is also staggering. Its sides are astonishingly straight and its vertices sharply defined, a level of precision that exceeds what most models predict. This has led some to wonder if we are seeing a natural phenomenon, but one that is being helped along or stabilized by something else entirely, perhaps a unique feature of Saturn's internal structure or composition that we have yet to discover. The natural explanation is powerful, but the extreme characteristics of the hexagon leave the door open for other, more extraordinary possibilities. This brings us to a crucial piece of the puzzle, the incredible speed at which Saturn itself is spinning. The planet completes a full rotation in just 10.5 hours, a dizzying velocity that whips its gaseous atmosphere into a frenzy. This rapid spin is the engine behind the powerful Coriolis effect, the force that deflects moving air and shapes weather patterns. On a world spinning that fast, the Coriolis effect is overwhelmingly dominant, acting as a master organizer for the chaos, imposing order where we would otherwise expect to find only turbulence. It provides the foundational force that allows such a stable, geometric pattern to emerge, and more importantly, to persist against the forces that would normally tear it apart. But rotation alone isn't enough. The incredible depth of Saturn's atmosphere plays an equally vital role in locking this shape into place. Unlike Earth's weather, which is largely a thin-skin phenomenon playing out in our troposphere, the processes that govern the hexagon are thought to extend hundreds of kilometers downward. This isn't a surface-level sketch, it's a deep-rooted atmospheric structure. Think of it like the difference between a leaf floating on the surface of a pond and a massive iceberg. The leaf is tossed and turned by every slight breeze and surface current. The iceberg, with its immense mass extending deep into the water, is stable, resistant to surface changes, and moves with a powerful, deliberate momentum. The hexagon is that iceberg. Its profound depth grants it a kind of inertial stability, making it resilient to the fleeting storms and temporary disturbances that churn the cloud tops above. The specific mechanism believed to be at work is a type of atmospheric wave known as a Rossby wave. On Earth, these large-scale waves meander through our jet stream, influencing our weather by creating high and low-pressure systems. But on Saturn, something extraordinary is happening to these waves. The theory suggests that a powerful jet stream, like a river of wind, acts as a waveguide. The stark difference in wind speed between this fast-moving jet and the slower-moving atmosphere surrounding it creates a sharp boundary, a kind of atmospheric wall that traps the energy of the Rossby wave, preventing it from dispersing. This trapped wave then begins to oscillate and reflect back on itself, eventually settling into a stable, standing pattern. It's a phenomenon you can observe on a much smaller scale. If you've ever seen a jump rope being shaken rhythmically, you might notice points along the rope that seem to be standing still while the wave energy moves through them. These are called standing waves. Now imagine that jump rope is a circular band of incredibly fast wind wrapped around Saturn's pole, and the person shaking it is the planet's own rotation and internal heat. The hexagon appears to be the visible manifestation of a planetary-scale standing wave, a fixed ripple in the fabric of Saturn's atmosphere where the wave's peaks and troughs have become permanently locked in place by the guiding forces of the jet stream and the planet's spin. This elegant interplay between rotation, depth, and wave dynamics presents a compelling natural explanation for one of the solar system's most stunning visual spectacles. While Saturn's hexagon presents a vision of almost mathematical order, the weather patterns we experience here on Earth offer a striking contrast in chaos and impermanence. To fully appreciate the uniqueness of that distant six-sided storm, it helps to look at our own planet's most powerful atmospheric phenomena. Both worlds possess polar vortices and high-altitude jet streams, but the comparison only serves to highlight how profoundly alien Saturn's environment truly is. Consider the polar vortex that forms over Earth's Arctic region each winter. This is a large area of low pressure and cold air that rotates counterclockwise, acting as a semi-contained whirlpool of frigid air. But unlike its Saturnian counterpart, our polar vortex is anything but stable or geometric. Its boundaries are fuzzy and irregular, constantly deforming as it interacts with warmer air masses from the south. It can stretch, split into multiple lobes, or even be displaced entirely, sending bursts of Arctic air deep into North America or Europe. This inherent instability is a direct result of Earth's diverse surface. Our mountains, oceans, and continents constantly disrupt and reshape the flow of air, preventing any lasting geometric order from taking hold. Our polar vortex is a transient feature, waxing and waning with the seasons, a slave to the complex topography beneath it. The behavior of Earth's jet streams further emphasizes this point. These ribbons of fast-flowing air high in the atmosphere are the steering currents for our weather, but they are meandering rivers, not rigid polygons. If you were to map the path of the northern jet stream over the course of a week, you would see a continually evolving series of giant waves called Rossby waves. These waves buckle and loop, creating deep troughs of cold air and massive ridges of warm air. They are the reason our weather is so difficult to predict beyond a few days. The system is fundamentally chaotic and sensitive to tiny changes in initial conditions. There is no persistent, straight-sided geometry here, only a beautiful, turbulent, and ever-changing flow. The difference in sheer scale is almost incomprehensible. Earth's entire diameter is just about 7,900 miles. A single side of Saturn's hexagon is longer than that. Our most powerful jet streams might reach widths of a few hundred miles and wind speeds of 200 miles per hour. The hexagon's jet stream is an order of magnitude more powerful and confined to a shape of staggering precision. This difference in scale directly contributes to the difference in behavior. On a small, topographically complex planet like Earth, weather is a messy, localized affair. On a massive, fluid world like Saturn, with no solid surface to create friction or disruption, atmospheric phenomena can achieve a kind of purity and scale we simply cannot replicate. This brings us to the most crucial distinction: geometry. On Earth, we see circles in hurricanes and typhoons, and occasionally fleeting hints of polygons in cloud formations, but nothing permanent or precise. Our atmosphere prefers curves and randomness, the path of least resistance. Saturn's hexagon, with its razor-straight sides and 60-degree angles, defies this expectation. It suggests that under the perfect conditions of immense scale, rapid rotation, and a uniform fluid environment, the atmosphere can indeed snap into a stable, ordered state, a state that, from our earthly perspective, appears almost engineered. The comparison doesn't necessarily disprove natural origins for the hexagon, but it powerfully illustrates that we are looking at a phenomenon operating under a completely different set of physical rules, on a canvas so vast it challenges our very understanding of what weather can be. This extraordinary stability over time is perhaps the most baffling aspect of the entire phenomenon. We've watched Earth's weather systems churn and change for centuries, and we've even witnessed the slow demise of Jupiter's Great Red Spot, a storm that once dwarfed our entire planet but is now gradually shrinking. Yet Saturn's hexagon remains a permanent fixture in the northern skies of that distant world, seemingly immune to the passage of time. It has persisted through nearly half a century of continuous observation, outlasting the missions that discovered it and the careers of the scientists who study it. This isn't a temporary arrangement of clouds. It appears to be a fundamental, enduring feature of Saturn's very atmosphere. The mystery deepens when we consider the tremendous seasonal shifts that Saturn experiences. A single year on Saturn lasts about 29.5 Earth years, meaning each season stretches for over 7 years. As the planet tilts on its axis throughout this long orbital dance, the amount of sunlight reaching the North Pole changes dramatically. For years, the pole experiences continuous darkness during its winter, followed by years of endless summer sunlight. On Earth, such radical changes in solar energy would completely reshape our atmospheric circulation patterns, yet the hexagon weathers these transitions without any noticeable effect. It operates with the same flawless geometry, whether bathed in constant sunlight or shrouded in the deep cold of polar night, suggesting its engine is powered from within the planet itself rather than by external heating from the sun. This incredible resilience points to something far more profound than surface-level weather. The hexagon appears to be anchored to something stable deep within Saturn's interior. While the cloud tops we see are turbulent and ever-changing, they may simply be the visible expression of a much deeper and more stable atmospheric structure. Picture a massive rock in a fast-moving stream. The water rushes around it, creating patterns and waves on the surface, but the rock itself remains unmoved. The hexagon might be the surface manifestation of such a fixed point, a permanent feature in the deep flow of Saturn's gaseous envelope that shapes everything above it into that unmistakable six-sided form. This level of permanence in a fluid environment is what truly separates the hexagon from anything in our experience. It suggests that beneath the apparent chaos of Saturn's atmosphere lies a hidden order, a set of physical laws operating on a scale and with a consistency we are only beginning to comprehend. The hexagon isn't just a beautiful curiosity. It is a natural laboratory showing us how stability can emerge from turbulence and how order can persist in an ever-changing system, challenging our assumptions about what is possible in planetary atmospheres. Yet for all its mathematical elegance, this natural explanation still leaves some scientists and researchers feeling unsettled. The sheer perfection of the hexagon's form, combined with its impossible longevity, nudges the mind toward a more extraordinary possibility. What if we are not looking at a natural wonder, but something else entirely? What if the precision of this structure is a signature, a telltale sign of intelligence at work? This line of thinking gives rise to the alien technology hypothesis, a provocative idea that suggests the hexagon might be a feat of mega-engineering, a constructed artifact on a planetary scale. Imagine a civilization so advanced that its technology is indistinguishable from the natural world. For such a society, manipulating the atmosphere of a gas giant might not be an impossible task but a grand project. One compelling speculation is that the hexagon could be a form of climate control or terraforming machinery. Saturn's atmosphere is a vast reservoir of resources, rich in helium-3 and other potential fuels. A stable, geometric weather pattern could act as a giant atmospheric processor, using the planet's own immense energy to separate and collect these valuable elements, essentially turning the entire North Pole into an automated mining and refinement facility. The hexagon's jet stream would be the conveyor belt, and its startling stability would be a necessary feature for consistent, long-term operation. Another fascinating concept is that of energy harvesting. Gas giants generate tremendous internal heat, and their rapid rotation creates powerful kinetic forces. A structure that locks onto the pole could function as a kind of dynamo, tapping into these planetary energies. The hexagon might be channeling this power, beaming it elsewhere, or using it to sustain other operations within the Saturnian system. Its geometric shape could be essential for focusing or containing these immense forces, much like the precise shape of a laser cavity is necessary to produce a coherent beam of light. From our distant vantage point, we would simply see a storm, but it could be the visible output of a sophisticated power generation system. The notion of a gateway or portal, often dismissed as pure science fiction, is also reinterpreted through this technological lens. Rather than a magical doorway to another dimension, it could be a stable navigational beacon or a vortex created for transportation. In the chaotic soup of a gas giant's atmosphere, having a fixed, predictable point of reference would be invaluable for any kind of travel or logistics. The hexagon could serve as a cosmic lighthouse or a docking station, its unmistakable geometric signature providing a fixed coordinate in a world without land. These ideas venture far beyond conventional science, but they stem from a simple, haunting question. In a universe vast and ancient beyond comprehension, is it more reasonable to believe such a perfect structure is entirely natural, or could it be the first evidence we are not alone? If such a structure were engineered, its potential purposes would dwarf any human undertaking, operating on a scale we can barely conceptualize. One of the most compelling scenarios is that of planetary stabilization. Saturn is a world of unimaginable atmospheric violence, a cauldron of screaming winds and titanic storms. An advanced civilization might seek to tame that chaos, not to make it habitable in the way we think of it, but to create a stable environment for their own incomprehensible technology. The hexagon could act as a giant regulator, a planetary thermostat that uses its geometric shape to contain and manage the immense energies within, preventing catastrophic atmospheric disruptions that could threaten whatever infrastructure might be hidden deeper within the planet's layers. It would be the ultimate shock absorber, turning a volatile, unpredictable environment into a controlled and predictable one. Beyond mere stabilization, the concept of energy harvesting becomes almost inevitable when considering the raw power at play. Saturn radiates more than twice the heat it receives from the Sun, a tremendous reservoir of internal thermal energy. Its rapid rotation generates colossal kinetic forces. For a sufficiently advanced species, this would not be a storm to be weathered, but a power plant to be tapped. The hexagon structure could function as a gravitational or atmospheric dynamo, its geometric precision essential for creating a standing wave that resonates with the planet's own frequency, effectively plugging into Saturn's very rotation and internal heat to draw out virtually limitless energy. This harvested power could be beamed across the solar system, used to fuel vast interstellar journeys or sustain other operations within Saturn's complex system of moons and rings. This leads to the provocative idea of resource processing. Gas giants are thought to be treasure troves of rare isotopes and gases like helium-3, which is a potential fuel for fusion reactors. The hexagon's violent jet stream racing along its six-sided track could be acting as a colossal centrifuge. Different gases and particles, subjected to these tremendous forces and precisely controlled patterns, could be separated and collected with astonishing efficiency. The entire polar region would become a natural refinery, its product being not gasoline or oil, but fuels for technologies that power civilizations across light years. The stability and longevity of the structure would be paramount for such an operation, requiring a constant, unchanging process that runs not for years but for millennia. Finally, we arrive at the most speculative yet fascinating purpose: geoengineering or terraforming on a grand scale. While we typically imagine terraforming as making a planet Earth-like for a species native to a gaseous environment, the goal would be utterly different. They might be engineering Saturn's atmosphere to create specific conditions altering its composition, temperature, or density to suit their biology or their technology. The hexagon could be the visible tip of a planet-wide project, the control mechanism for a process that is slowly, over eons, transforming the entire world from the pole downward. It stands as a permanent monument to a project whose end goal and timeframe are so vast, we lack the perspective to even recognize its progress. Whether for stability, power, resources, or transformation, the hexagon challenges us to consider that the most stunning phenomena in the cosmos might not just be natural wonders to observe, but engineered artifacts to decipher. But perhaps the most captivating and speculative idea of all transcends mere engineering and ventures into the realm of the truly cosmic. The possibility that the hexagon is not a machine in the conventional sense but a gateway. This concept, often brushed aside as pure science fiction, nevertheless finds a curious foothold in some of the most advanced areas of theoretical physics. Imagine if the immense rotational energy and unique atmospheric conditions at Saturn's pole don't just create a weather pattern, but somehow interact with the very fabric of space-time itself. Under such extraordinary circumstances, could this geometric marvel be a natural or artificial vortex, a stable doorway to another place or even another dimension? The science fiction parallels are immediate and powerful, from the stargates of popular cinema to the wormholes of interstellar travel narratives. These stories tap into a deep human fascination with shortcuts across the cosmos. Theoretical physics tells us that such structures, known as traversable wormholes, could be possible within the framework of Einstein's equations, though they would require forms of matter and energy with exotic properties to remain stable, things like negative energy densities that we have not yet discovered or learned to create. The hexagon, with its seemingly impossible stability and deep-rooted connection to Saturn's immense gravitational and rotational forces, presents a location where the conditions to support such a structure might be found. Its geometric perfection could be less about engineering and more about resonance, a specific, stable frequency necessary to hold a spatial or dimensional tier open against the forces that would otherwise cause it to collapse instantly. This theory reinterprets the hexagon not as a storm to be weathered, but as a landmark to be navigated. In the overwhelming chaos of a gas giant's atmosphere, a fixed, predictable, and unmistakable geometric point would be the ultimate beacon. It could serve as a natural coordinate system, a fixed address in a world without surface features. For a civilization capable of manipulating space-time, this stability would be indispensable, making the pole the only logical location for any kind of permanent transit infrastructure. The hexagon wouldn't be the portal itself, but the immense, visible anchor point for the monumental architecture marking the entrance to a cosmic highway. Whether as a storm, a machine, or a gateway, Saturn's hexagon endures as one of our solar system's most profound puzzles. Each explanation, from the rigorously scientific to the wildly speculative, challenges our perspective and expands our understanding of what is possible. It forces us to look at a perfect geometric shape etched into the clouds of a distant world and ask not just how, but why. The answer, whatever it may be, promises to redefine our place in a universe that is far stranger and more wonderful than we ever imagined. Of course, the most scientifically rigorous path is one of healthy skepticism. The mainstream scientific community, while fascinated by the hexagon, largely views the alien technology or gateway hypotheses as fascinating thought experiments rather than viable theories. The guiding principle here is Occam's razor, the idea that among competing explanations, the one with the fewest assumptions is usually correct. When we apply this razor to Saturn's hexagon, the natural atmospheric model, for all its remaining questions, requires far fewer leaps of faith than theories involving unknown, hyper-advanced intelligences and physics-defying technology. It asks us to extend our understanding of known physics to new extremes, rather than invent entirely new categories of explanation from whole cloth. The central demand of science when faced with such an extraordinary claim is simple, extraordinary evidence. Proposing an alien origin isn't just another idea. It's a monumental claim that would fundamentally rewrite our understanding of the universe and our place within it. To support it, we would need evidence that is equally monumental and utterly unambiguous. We would need to detect structured signals or patterns within the hexagon that defy any known natural process. We might look for signs of concentrated energy beams, artificial structures within or below the clouds, or even evidence of purposeful modification of the surrounding environment, none of which have been observed. The data from Cassini and our telescopes, while revealing a stunning natural phenomenon, have so far provided no such smoking gun. The hexagon is bizarre, but its bizarreness still operates within the realm of fluid dynamics and wave theory, however pushed to their limits. It's also worth noting that human history is littered with examples of attributing the unexplained to the supernatural or the extraterrestrial, only to later discover a perfectly natural cause. Lightning was once the weapon of angry gods. The planets were wandering deities. Canals on Mars were evidence of a dying civilization. In each case, as our scientific tools and understanding improved, the magical thinking receded, replaced by a deeper, more profound appreciation for the natural world's own complexities. The hexagon could very well be the next chapter in this long story, a puzzle that seems supernatural only until we finally crack the code, revealing a new and beautiful law of planetary physics we never knew existed. This isn't to say scientists dismiss the possibility of extraterrestrial life. Many are actively searching for it, but the approach is methodical and evidence-based. The search for extraterrestrial intelligence, or SETI, focuses on scanning the cosmos for deliberate signals, a clear sign of technology. Astrobiology looks for biosignatures, chemical imbalances in atmospheres that might indicate biological processes. Saturn's hexagon as a potential technosignature doesn't neatly fit. It doesn't transmit a signal, and its composition, while unique, doesn't point directly to an artificial process. Invoking aliens to explain it is essentially our argument from ignorance, stating that because we don't fully understand it yet, it must be artificial. Science, however, thrives on ignorance. It's the frontier of the unknown that drives research and discovery, and filling that gap with aliens effectively halts the scientific process. The natural explanation, while incomplete, has a powerful advantage: it's testable. Researchers can refine their fluid dynamics models. They can run new laboratory experiments with different viscosities and rotation speeds. They can look for similar, smaller-scale polygonal shapes in other atmospheric data, perhaps on Jupiter or even in the oceans of Earth. Each observation either supports or refutes the model, allowing it to be gradually improved. The alien hypothesis, by contrast, is much harder to test in any meaningful way. How do you prove a negative? How do you definitively rule out an invisible, hyper-advanced technology that, by its very definition, might be indistinguishable from nature? This lack of falsifiability places it outside the bounds of conventional scientific inquiry, making it more a matter of philosophy and speculation than empirical science. Ultimately, the scientific skepticism isn't about closing doors to wonder. It's about ensuring our sense of wonder is directed by evidence and reason. The natural explanation for Saturn's hexagon, a self-organizing atmospheric wave born from unimaginable rotation and depth, is in its own right utterly spectacular. It reveals a universe capable of creating perfect geometry on a planetary scale through the blind forces of physics, a concept that is arguably more awe-inspiring than simply chalking it up to aliens. It suggests that nature's toolbox is far more vast and creative than we often give it credit for, holding wonders that can humble us without requiring us to invent cosmic engineers. The hexagon remains a profound mystery, but for now, the most scientific stance is to continue marveling at it as a masterpiece of natural planetary art, while relentlessly seeking the physical brushstrokes that painted it. At the very heart of this six-sided enigma lies another, perhaps even deeper mystery, a massive, swirling vortex that acts as the hexagon's central anchor point, often referred to as its eye. This is not a passive hole in the storm, but a dynamic, powerful hurricane-like system all its own, drawing immediate and fascinating comparisons to the most famous storm in our solar system, Jupiter's Great Red Spot. But while the Great Red Spot is a sprawling, oval-shaped anticyclone, a high-pressure system rotating counter-clockwise, the eye of Saturn's hexagon is a profoundly different beast, operating under a unique set of rules that may hold the key to the entire structure's incredible stability. This central vortex is a colossal storm in its own right, a roiling maelstrom of gas with its own complex internal dynamics. Unlike the clear, calm eye found at the center of a terrestrial hurricane, Saturn's polar vortex is a place of immense energy and activity. Cassini's instruments revealed it to be a towering structure, reaching hundreds of kilometers high, with clouds that whip around at terrifying speeds. Its most startling feature, however, is its shape. While most vortexes, from your bathtub drain to Jupiter's giant storm, are roughly circular, the eye at Saturn's pole is not a perfect circle. High-resolution imagery has shown it to have a slightly polygonal shape itself, often appearing as a six-sided spiral within the larger six-sided frame, as if the geometry of the hexagon is echoing inward, down to the very core of the storm. This nested, fractal-like quality suggests a deep and fundamental connection between the central vortex and the overarching jet stream that defines the hexagon's boundary. The relationship between the eye and the hexagon appears to be symbiotic, a delicate and powerful feedback loop. The prevailing scientific theory suggests that the central vortex is not merely a passenger within the hexagon, it is likely the very engine that drives it. Think of it as a massive spinning top set down at the North Pole. As this giant vortex churns, it interacts with the deeper layers of Saturn's atmosphere, potentially generating the powerful eastward jet stream that forms the hexagon's outer edge. The vortex's rotation could be the primary source of energy that injects momentum into the system, helping to sustain the standing wave pattern against the dissipative forces of friction and turbulence that would otherwise cause it to break down and fade away. This dynamic offers a potential explanation for the hexagon's mind-boggling longevity. The Great Red Spot, for all its fame, is slowly shrinking and is believed to be powered by the absorption of smaller storms, a fuel source that may eventually run out. Saturn's polar vortex, by contrast, seems to be tap dancing with the planet itself. Its position, fixed directly over the pole, may allow it to draw energy more directly from Saturn's internal heat flow and its rapid rotation. It is not just a storm feeding on other storms, it is a fundamental component of the planet's global atmospheric circulation, a permanent feature plugged directly into the world's core power supply. This deep connection could be why it has remained stable and unchanged for over 40 years of observation, outlasting every spacecraft sent to study it. The slightly polygonal shape of the vortex itself provides another crucial clue. It indicates that the vortex is not operating in isolation. It is locked in a tight, resonant dance with the hexagonal jet stream surrounding it. The straight sides of the hexagon exert an influence on the vortex, shaping its outer boundaries and preventing it from achieving a perfect circular form. In return, the vortex's stability helps to pin the larger hexagonal pattern in place, preventing it from drifting or breaking apart. They are two parts of a single, interconnected system. One cannot exist without the other. This intricate partnership between a central storm and a geometric boundary wave may be the secret recipe that allows such perfect order to emerge from the atmospheric chaos of a gas giant, a phenomenon we have yet to witness anywhere else in our solar system. While the hexagon dominates Saturn's northern skies, its influence may extend far beyond the cloud tops, potentially reaching across the void to interact with the planet's most iconic feature, its magnificent ring system. At first glance, this seems implausible. The hexagon is an atmospheric phenomenon rooted deep in the polar weather, while the rings are a separate system of countless ice particles orbiting far above the equator. They are separated by tens of thousands of miles and exist in entirely different regimes of physics. Yet, on a planet where rotation is king, no part of the system is truly isolated. The entire Saturnian environment is a single, interconnected entity, bound together by the invisible threads of gravity and magnetism, and the hexagon's immense energy might just be sending ripples through it all. The most plausible connection lies in the realm of gravity. The hexagon is not merely a pattern of clouds, it is a manifestation of a massive standing wave, a deep-rooted density oscillation in the atmosphere. Such a colossal structure, with its incredible mass and precise, stable rotation, Chinese letter generates its own subtle gravitational signature. While minuscule compared to the pull of the entire planet, this gravitational anomaly could, in theory, exert a tiny but persistent tidal force on the ring particles. It would act like a distant, rhythmic drumbeat, its six-sided pattern potentially imprinting a faint, wave-like disturbance in the ring material. Scientists actively search for such patterns, spiral density waves triggered by the gravitational tug of orbiting moons. Could the hexagon, a fixed atmospheric feature, produce a similar, albeit vastly weaker, effect? It's a tantalizing thought, though no such correlation has been definitively observed, suggesting that if this link exists, its signal is buried deep within the noise of more powerful influences. A more compelling avenue of connection is through Saturn's powerful magnetic field, generated by the churning of metallic hydrogen deep in the planet's interior. This magnetic field is like a giant, invisible cocoon enveloping Saturn, its rings, and many of its moons. The hexagon, with its screaming winds and deep atmospheric currents, is essentially a vast river of electrically charged particles moving through this magnetic field. This movement should, according to fundamental physics, induce electrical currents and create secondary, localized magnetic anomalies. Think of it as a planetary-sized dynamo where the motion of the atmospheric conductor through the magnetic field generates its own electromagnetic field. This hexagon-induced field would be incredibly complex and dynamic, twisting and turning with the six-sided flow. The rings, composed of ice particles, some of which are electrically charged and susceptible to magnetic influences, could be feeling the faintest whisper of this effect. It might not be enough to sculpt the rings visibly, but it could contribute to the complex plasma environment that surrounds them, potentially influencing the distribution of tiny, charged dust grains. This creates a fascinating feedback loop. The planet's internal magnetic field shapes the hexagon's behavior, and the hexagon, in turn, subtly distorts that same field in its local region, creating a unique magnetic fingerprint that extends into space and might just brush against the inner edges of the ring system. It's an invisible conversation between cloud and ring, conducted not through sound, but through the silent language of electromagnetic forces. Beyond these physical forces, the connection might be more fundamental, rooted in a shared rhythm. Both the hexagon and the rings are ultimately slaves to Saturn's rapid rotation. This spin provides the foundational beat that orchestrates all large-scale motion around the planet. The precise geometric order of the hexagon and the intricate ring structure both emerge from the interplay of motion and gravity under this constant rotational force. They are different expressions of the same underlying physics, playing out in different parts of the Saturnian sphere. The rings display their own astonishing geometric features, like the intricate spiral density waves and sharp gaps created by gravitational resonances with moons. In a way, the hexagon is the atmosphere's answer to these ring features, a resonant structure locked into a stable pattern by the planet's spin. They are not directly causing each other, but rather they are siblings, both born from the same parental forces of rotation and gravity, making them kin in the grand family of Saturn's phenomena. This incredible stability faced its greatest test not from internal chaos, but from an external force, the slowly shifting gaze of the Sun. Saturn's journey around our star creates seasons of almost unimaginable length, each lasting over 7 Earth years. For the majority of the time we've been observing it, the hexagon has been shrouded in the deep, frigid darkness of a polar winter, a period of perpetual night where temperatures plummet and atmospheric activity is hidden from view. The arrival of the Cassini spacecraft coincided with a monumental celestial event, the dawn of spring in Saturn's northern hemisphere. For the first time, we had a front-row seat to witness how this perfect geometric storm would respond as sunlight finally crept back over the pole, bathing it in a warmth it hadn't felt in over a decade. What we observed was a transformation, but not of the hexagon's fundamental structure. Its 6-sided shape and furious jet stream remained utterly unshaken, a testament to its deep-rooted nature. The changes were more subtle, a shift in hue and character rather than form. As sunlight penetrated the high-altitude haze, Cassini's cameras documented a fascinating color change across the polar region. The hexagon, which had appeared in a relatively uniform, bland yellowish during the winter, began to develop a distinctly bluish tint at its center and along the inner edges of its walls. This wasn't a simple artistic flourish, it was a critical clue written in light and chemistry, revealing the atmospheric processes at work. Scientists interpreted this color shift as a direct result of increasing solar radiation. The prevailing theory suggests that the prolonged darkness of winter allows a thick photochemical smog to build up in the upper atmosphere. This haze, created by the interaction of solar ultraviolet light with methane gas, gives the clouds their muted golden-brown appearance. When sunlight returns in spring, it acts like an atmospheric cleanser. The increased ultraviolet radiation likely helps to break down this haze through chemical reactions, essentially scrubbing the upper atmosphere and allowing us to see deeper down to a layer of clearer bluish clouds. The hexagon's jet stream might act as a barrier, containing this process within its walls and creating the sharp color contrast we observed. It was as if we were watching a planetary-scale curtain being drawn back, revealing a clearer sky beneath. Beyond color, the increasing solar energy also triggered a dramatic shift in the cloud patterns themselves, particularly within the hexagon's central vortex. During the long winter, the eye of the storm was a relatively featureless, though turbulent, pool of swirling gas. With the return of sunlight, Cassini witnessed the birth of a spectacular, smaller-scale storm system within the vortex, a massive, swirling beacon of convective activity. This wasn't a gentle transformation. It was the eruption of a dynamic new weather feature, likely driven by the sun's warmth creating instability and driving powerful updrafts from the warmer layers below. Imagine the difference between a calm, cold winter's day and the explosive development of a thunderstorm on a hot summer afternoon. Cassini showed us the Saturnian equivalent unfolding over years, not hours. This profound seasonal response tells us something crucial about the hexagon's nature. It demonstrates that while the structure's engine is undeniably powered from within by the planet's own rotation and internal heat, the visible face it shows the universe is exquisitely sensitive to external influences. The sun doesn't power the hexagon, but it does paint it. It dictates the chemistry of the high-altitude haze and provides the energy for convective storms to brew within its stable confines. The hexagon, therefore, exists in a perfect balance. Its foundational stability is guaranteed by the deep mechanics of Saturn itself, while its appearance is a dynamic canvas upon which the seasons slowly, deliberately leave their mark. It is both a permanent feature of the planet and a transient display of atmospheric artistry, changing its colors with the slow turn of a cosmic year. While our eyes see a stunning geometric pattern, the true nature of Saturn's hexagon is written in wavelengths of light invisible to us. By looking beyond the visible spectrum, the Cassini spacecraft transformed from a simple camera into a sophisticated diagnostic tool, allowing scientists to take the hexagon's temperature and analyze its chemical bloodwork. These observations didn't just add detail to the picture, they revealed an entirely new layer of complexity, showing that the hexagon is far more than a cloud-top phenomenon. It is a deep, dynamic, and thermally active structure with secrets that continue to challenge our models. In the infrared spectrum, which measures heat radiation, the hexagon revealed a startling thermal profile. The most striking feature was a massive, swirling vortex of warm air locked directly at the center of the hexagon over the North Pole. This wasn't a uniform pool of warmth. It was a towering, hurricane-like system, hundreds of kilometers high, with temperatures significantly higher than the surrounding atmosphere. This warm polar vortex acts as the heart of the entire system, and its stability is likely a key reason the hexagon itself is so enduring. The infrared data showed that this vortex is not a shallow feature. It extends deep into the atmosphere, a chimney of relatively warmer air that seems to be funneling internal heat from the planet's depths up toward the cloud tops. This deep-rooted heat source provides a constant energy supply, helping to power the jet stream and maintain the standing wave against the forces of dissipation. But the thermal story gets even more intriguing when we look at the hexagon's walls themselves. The infrared eyes of Cassini detected a clear and persistent temperature difference between the inside and outside of the hexagonal jet stream. The air inside the hexagon's boundary was consistently cooler than the chaotic atmosphere outside of it. This creates a sharp thermal gradient right along the jet stream's path. This temperature difference is critical because it helps to maintain the sharp velocity gradient of the winds. The contrast essentially reinforces the wall of the hexagon, preventing it from diffusing and blurring over time. It's a self-reinforcing system. The fast-moving wind creates the thermal boundary, and the thermal boundary helps to sustain the fast-moving wind. When Cassini turned its ultraviolet spectrometers toward the hexagon, it began to read the chemical signature of this vast atmospheric structure. UV observations are excellent at detecting the presence of specific aerosols and haze particles high in the atmosphere. What they found was a distinct chemical divide that perfectly mirrored the hexagon's geometric shape. Inside the hexagon, the upper atmosphere appeared to be clearer, with fewer of the thick, photochemical haze particles that give Saturn its familiar golden-brown hue. Outside the hexagon, this haze was much denser. This suggests that the hexagon's jet stream acts as a powerful atmospheric barrier, not just for wind and temperature, but for chemistry as well. It effectively isolates the air mass within its walls, preventing the haze that forms outside from mixing in and contaminating the inner environment. This creates a unique chemical microclimate within the hexagon, a region with its own distinct atmospheric composition. Perhaps the most significant anomaly revealed by this multi-wavelength analysis is the incredible depth of the entire structure. By combining data from visual, infrared, and radio occultation, experiments where Cassini measured how Saturn's atmosphere bent radio signals from Earth, scientists were able to construct a three-dimensional map of the hexagon. The results were staggering. The hexagonal pattern isn't a skin-deep drawing on the cloud tops. It is a monumental tower of weather, a wave that propagates vertically for hundreds of kilometers down into the atmospheric abyss. This enormous depth is a double-edged sword for scientists. On one hand, it strongly supports the natural standing wave theory, as such deep-rooted waves are known to be exceptionally stable. On the other hand, the sheer scale and perfection of this deep structure push our current shallow water atmospheric models to their absolute limits and perhaps beyond. We simply don't have a complete model that can perfectly replicate a stable, geometric wave of this immense vertical extent. These observations in non-visible light ultimately paint a picture of the hexagon as a profoundly coherent atmospheric system. It isn't just a pattern of clouds, it is a unified structure that manifests simultaneously across multiple parameters: wind speed, temperature, chemical composition, and density, all locked into the same precise six-sided geometry. This coherence across different layers and properties is what truly separates it from any other weather phenomenon we know. It behaves less like a storm and more like a single, gigantic organism of weather, with all its parts working in concert to maintain its unique and beautiful form against the relentless chaos of the Saturnian sky. This incredible coherence across multiple dimensions of measurement invites a truly fascinating line of inquiry, one that moves beyond what we can see and into what we might be able to hear. If the hexagon is indeed a planetary scale standing wave, a stable oscillation in the atmosphere, then it should have a frequency. It should, in essence, be producing a sound. Scientists, with their characteristic blend of curiosity and ingenuity, decided to try and listen to it. By translating the hexagon's visible motion into data, they could calculate its fundamental frequency and shift that frequency into the range of human hearing. The result is not a chaotic storm noise, but something far more structured and profound, a deep, resonant, and haunting hum. The process of hearing the hexagon is a feat of scientific translation. Researchers began by meticulously analyzing years of imagery from the Cassini spacecraft, precisely tracking the movement of clouds along the hexagon's six-sided boundary. They measured the velocity of the jet stream and the time it takes for a single wave to complete a journey around the massive structure. This data allowed them to calculate the wave's period, the time for one complete oscillation. The fundamental frequency of this oscillation was determined to be incredibly low, far below the threshold of human hearing. To make this infrasound accessible to us, scientists then had to speed up the data, shifting the pitch of this planetary note upward by a significant amount. What emerges from the speakers is not the actual sound in space, but a sonification, an audio representation that faithfully preserves the harmonic character of the phenomenon. The sound itself is arresting. It is a deep, steady, and somewhat melancholic drone, a single, persistent note that seems to vibrate with a palpable sense of power and age. There are no cracks of lightning or howls of wind in this rendering. It is a pure tone, the auditory signature of a perfectly stable oscillation. This isn't the sound of chaos, but the sound of order emerging from chaos on an unimaginable scale. For many who hear it, the immediate association is with something manufactured, like the deep idle of a massive engine or the resonant hum of a high-tension power line. This auditory quality is perhaps one of the most psychologically compelling aspects of the entire mystery because it feels engineered. It resonates with our intuitive understanding of how machines sound, making the leap to artificiality feel disturbingly natural. From a purely scientific standpoint, this resonant hum is a powerful validation of the standing wave theory. all standing waves from a vibrating guitar string to the air column in a pipe organ have a fundamental frequency and a set of harmonics higher frequency notes that are integer multiples of the fundamental. The clean, tonal quality of the hexagon sonification suggests a remarkably pure wave with few competing harmonics, indicating a system that is locked into a very stable and efficient resonance. This is exactly what physicists would expect from a large-scale atmospheric wave guided by a jet stream and reinforced by the planet's rapid rotation. The sound is the natural voice of this precise physical process, yet the perfection of that tone is also what fuels more speculative wonder. In our everyday experience, pure, sustained tones are almost always the product of intention. A humming engine, a singing wine glass, a struck tuning fork, these are sounds created by designed objects whose shape and material are crafted to resonate at a specific frequency. We do not often encounter a pure tone emerging spontaneously from a chaotic natural system like a planetary atmosphere. Even our own planet's resonant frequencies, known as Schumann resonances, which are caused by lightning exciting the cavity between Earth's surface and the ionosphere, are a messy chorus of overlapping frequencies, not a single clean note. The hexagon's hum is singular and unwavering by comparison. This leads to a provocative question: could this resonant frequency be more than a simple byproduct of physics? If one were to hypothesize an artificial structure, its primary purpose would likely involve stability and energy efficiency. A precise geometric shape resonating at a specific, stable frequency is the hallmark of efficient energy transfer in engineering. In crystal oscillators that keep time in our electronics, or in the carefully tuned cavities of a particle accelerator, resonance is used to maximize energy and maintain perfect stability. The hexagon's hum could be interpreted as the audible output of a system operating at peak efficiency, its tone signifying that it is perfectly tuned and functioning as intended, drawing maximum energy from Saturn's rotation with minimal loss. Whether the product of breathtaking natural physics or unimaginable engineering, the hexagon's deep hum connects with us on a primal level. It transforms this distant, visual mystery into something we can almost feel in our bones. It is a reminder that the universe is not a silent vacuum, but a symphony of vibrations operating at scales both microscopic and galactic. The hexagon's song is a lone note in that cosmic symphony, a drone that has persisted for decades and perhaps for centuries, a permanent fixture in the music of the spheres. It is the sound of Saturn itself, a giant's heartbeat echoing through the dark, and whether natural or artificial, it remains one of the most haunting and beautiful sounds in our solar system. To understand the true uniqueness of Saturn's hexagon, we must widen our gaze and explore the rest of our solar system, searching for other geometric patterns etched into alien landscapes. This field, known as comparative planetology, allows us to see Saturn's wonder not in isolation, but as part of a broader cosmic family of phenomena. And what we find is that while other worlds have hints of geometry, nothing compares to the ringed planet's perfect, persistent six-sided storm. Our first stop is Jupiter, a gas giant sibling to Saturn, and a world that also boasts stunning polar patterns. NASA Juno spacecraft has revealed that both of Jupiter's poles are crowned with sprawling, chaotic clusters of cyclones. At the North Pole, 8 smaller storms whirl tightly around a single central cyclone. At the South Pole, 5 storms perform a similar dance. These are undoubtedly geometric arrangements, but they are fundamentally different from Saturn's hexagon. They are collections of individual, distinct storms, each with its own eye and identity, orbiting each other in a delicate and turbulent gravitational balance. They are more like a school of fish swimming in a circle than a single, continuous structure. Their polygons are emergent, a result of complex storm interactions, and they can and do change over time. Saturn's hexagon, by contrast, is a monolithic jet stream, a single, unified river of wind holding its geometric shape against all odds. Closer to home, we find a fascinating terrestrial analog in the Arctic Ocean. During the winter, when sea ice forms on the polar waters, it doesn't always create a smooth, uniform sheet. Under the right conditions, particularly when currents and winds stress the ice, it can fracture into startlingly geometric patterns. Vast sheets of ice can break into large, tile-like polygons, often hexagons or pentagons, separated by cracks and ridges known as leads. This is a beautiful example of nature's tendency toward geometry, but its origins are purely mechanical. The ice is a solid, brittle sheet being pushed and pulled by forces until it cracks along the lines of least resistance, often forming angles of 120 degrees, which naturally creates hexagons. It's a process of fracture and stress relief, not a dynamic atmospheric wave. The scale is also minuscule compared to Saturn. While impressive from an airplane window, these ice polygons are measured in meters or kilometers, not the tens of thousands of kilometers that define the hexagon. Even our own atmosphere occasionally offers fleeting glimpses of polygonal shapes. Certain rare types of high-altitude clouds and the complex interference patterns that can sometimes be seen in radar scans of large storm systems can manifest temporary hexagonal or honeycomb structures. But these are ephemeral ghosts in the machine, lasting for hours at most before the relentless chaos of Earth's weather tears them apart. They are brief accidents of fluid dynamics, not permanent fixtures. Their impermanence only serves to highlight the most staggering difference between every other example and Saturn's masterpiece, time. The hexagon has been a fixed, unchanging feature for over 4 decades of continuous observation, and likely for centuries before we first spotted it. It is a permanent tattoo on the face of Saturn, while every other polygonal pattern in our solar system is a temporary sketch, quickly drawn and just as quickly erased by the elements. This journey across our celestial neighborhood reveals a critical truth. Other planets and moons show us that geometric patterns can emerge naturally from the physics of fluids, rotating systems, and solid materials under stress. They are part of nature's diverse toolkit, but what we find at Saturn's North Pole is in a category entirely of its own. It is the only example of a perfect, large-scale, stable, and deeply rooted geometric atmospheric wave on a planetary scale. It combines immense size, shocking precision, unbelievable power, and timeless endurance in a way that exists nowhere else we have ever looked. This comparative study doesn't diminish the hexagon's mystery, it magnifies it. By showing us what is possible elsewhere, it throws Saturn's six-sided wonder into even sharper relief, proving that while nature can draw polygons, only on Saturn has it chosen to sign its name with one. This immense internal furnace is arguably the unsung hero of the hexagon story, the hidden power source that makes its long-term stability even possible. While the planet's rapid rotation provides the organizing principle, its internal heat provides the raw energy that keeps the entire system churning against the forces of friction that would otherwise cause it to slowly wind down and dissipate. Unlike Earth, which is primarily warmed by the sun, Saturn generates most of its own heat from within. In fact, the planet radiates nearly 2.5 times more energy into space than it receives from our star, a surplus that must have a profound and continuous source. Scientists believe this internal heating stems from a fascinating process deep within the planet's interior. As Saturn gradually cools down from its original hot formation over 4.5 billion years ago, helium droplets are condensing out of the metallic hydrogen layer deep inside and falling like rain towards the core. This slow, gravitational descent of denser material releases tremendous amounts of potential energy, which is converted into heat. This process, known as helium precipitation, acts as a massive planet-scale engine, constantly stoking the fires of Saturn's atmosphere from the bottom up. This internal heat doesn't just warm the planet, it drives a monumental engine of convection. Think of a pot of water boiling on a stove. The heat at the bottom causes the water to become less dense and rise in plumes towards the surface, where it cools, becomes denser again, and sinks back down to be reheated, creating a continuous cycle of motion. Now imagine that pot is the entire planet of Saturn, and the water is an atmosphere tens of thousands of miles deep. The heat from the core generates colossal convective updrafts, massive columns of warm gas rising from the abyss towards the cloud tops. These rising plumes are the fundamental drivers of Saturn's weather, the pistons in its atmospheric engine. This is where we can begin to connect the deep interior to the geometric perfection at the pole. These powerful convective updrafts, as they rise, eventually slam into the stable, stratified layers of the upper atmosphere. This collision is like an underwater geyser hitting the surface of the ocean. It creates a disturbance, a ripple that propagates outward. On a rapidly spinning planet like Saturn, the omnipresent Coriolis force immediately seizes control of these ripples, shaping them and organizing their energy. It is widely theorized that the hexagon standing wave is the ultimate expression of this process, a stable, resonant pattern that emerges from the constant injection of energy from these deep convective forces, organized by the planet's spin. The warm polar vortex observed at the hexagon's center provides a critical piece of evidence for this deep energy connection. Infrared measurements show this vortex is significantly warmer than its surroundings and extends hundreds of kilometers downward. This suggests it isn't a superficial weather feature, but rather the surface manifestation of one of these massive convective heat plumes, a planetary-scale chimney funneling warm internal gas directly up to the cloud tops. This persistent upwelling at the pole likely acts as the anchor for the entire hexagonal system. It provides a steady and reliable source of energy and momentum, helping to power the jet stream and lock the standing wave into its precise, stable configuration season after season, decade after decade. The hexagon, therefore, is not just a drawing in the clouds, it is a window into the fiery, dynamic heart of Saturn itself, a visible signature of the deep forces that have shaped this gas giant since its birth. If such a structure were indeed engineered, the technology required would operate on principles far beyond our current grasp of physics, leveraging the planet's own immense energies with breathtaking efficiency. One compelling possibility involves the manipulation of plasma. Saturn's upper atmosphere is a soup of ionized particles, and a sufficiently advanced technology could use precision magnetic fields to sculpt this plasma, guiding it into a stable, six-sided circuit. This conductive loop, acting like a superfluidic electrical wire, could then interact with the planet's own powerful magnetosphere, creating a self-reinforcing feedback loop that shapes the weather around it. Think of it not as building a wall, but as drawing a line of force in the sky with a magnetic pen, a line that the charged atmosphere is compelled to follow. The heart of such a system would likely be a network of magnetic field generators, positioned deep within the atmosphere where pressure and temperature are extreme. These wouldn't be solid machines as we imagine them, but perhaps dynamic structures composed of force fields themselves, using the superconducting properties of metallic hydrogen deep within Saturn to amplify their effect. They could create a series of stable magnetic anchors at the 6 vertices of the hexagon, pinning the jet stream in place with invisible tethers of pure energy. The screaming winds would be herded along this predetermined path, much like the charged particles in a particle accelerator are steered by powerful magnets, their chaotic energy channeled into a perfectly geometric racetrack. Another avenue delves into the exotic realm of quantum fluid controls. At the extremely low temperatures found high in Saturn's atmosphere, certain gases can enter a superfluidic state, a bizarre phase of matter where viscosity vanishes and flow becomes perfectly efficient without any loss of energy. A technology capable of initiating and maintaining a superfluidic state on a planetary scale could essentially lock in the hexagonal pattern. Once established, this superfluidic circuit would require no additional energy to maintain its motion. It would simply continue flowing in its geometric path indefinitely, a perpetual motion machine carved into the sky, immune to the friction and turbulence that would normally degrade any storm system. The power source for such an undertaking is almost unimaginable, but Saturn itself provides the obvious answer: its own rotation. The planet is a colossal spinning top, storing a truly astronomical amount of kinetic energy. An advanced civilization could tap this spin directly, using the principle of electromagnetic induction. Massive structures, or perhaps even arranged patterns of force, could function as a dynamo, resisting the planet's magnetic field as it spins. This would generate immense electrical currents, effectively bleeding off a tiny fraction of Saturn's rotational momentum to power the hexagon's stabilizing mechanisms. The entire structure would act as a brake on the planet's spin, but over timescales so vast that the change would be imperceptible even over millennia. Perhaps the most intriguing mechanism involves creating a resonant standing wave not just in the atmosphere, but in space-time itself. Some speculative theories in physics suggest that extremely massive, rapidly rotating objects can create frame-dragging effects, subtly twisting the fabric of the universe around them. A technology that could amplify and precisely tune this effect might be able to imprint a geometric pattern onto the local curvature of space-time. The hexagon's jet stream would then simply be the visible atmosphere flowing along the grooves of this invisible, six-sided gravitational contour, like water finding the path of least resistance down a drain. The hexagon wouldn't be controlling the weather, it would be controlling the geometry of gravity itself, and the weather would have no choice but to obey. This striking celestial geometry has resonated far beyond the laboratories of scientists and observatories, sparking the collective imagination and permanently etching itself into our culture. The moment that first crisp, six-sided image from Cassini hit the public consciousness, it was as if a cosmic Rorschach test had been administered to humanity. For writers, filmmakers, and game developers, the hexagon became an irresistible symbol, a ready-made monument of mystery that required no artistic embellishment to feel utterly alien. Its perfect form, so out of place in a natural universe of curves and chaos, seemed to beg for a narrative, and we were all too eager to provide one. In the realm of science fiction literature, the hexagon has been reimagined as the ultimate archaeological site. Numerous novels portray it not as a storm, but as the exposed, weathered surface of a machine so vast its true purpose is incomprehensible. In these stories, it is often the first clue humanity discovers of a precursor civilization, a species so advanced they could engineer the very weather patterns of a gas giant. The hexagon becomes a puzzle box to be unlocked, its geometric perfection the key to either unimaginable power or unspeakable peril, serving as a powerful metaphor for humanity's own thirst for knowledge and the dangers that might accompany such a discovery. These narratives tap into a deep-seated wonder about our place in the cosmos and the possibility that we are living among the ruins of gods. Blockbuster cinema has eagerly adopted the hexagon as a visual shorthand for the cosmic unknown. It has appeared, often with dramatic artistic license, as a stable wormhole leading to another galaxy, a dimensional rift threatening to consume the solar system, or the outermost security barrier for a hidden civilization living within Saturn itself. Filmmakers understand its visual power instantly. It looks designed. This immediate, visceral reaction allows them to bypass lengthy exposition. The audience sees that impossible shape and instantly accepts its artificiality within the context of the story, making it the perfect gateway to adventures that defy conventional physics. It is the modern equivalent of the crystalline monolith from 2001, a silent, geometric enigma that promises a story far greater than our own. The video game industry, with its emphasis on interactive exploration, has perhaps found the most compelling use for the hexagon. In sprawling space exploration simulators and narrative-driven adventures, it is frequently the ultimate destination, a late-game location shrouded in myth and danger. Players might be tasked with navigating its turbulent jet stream to reach a stable center, which often houses a pivotal story revelation, an ancient alien archive, a powerful weapon, or the answers to a galactic extinction event. Game designers leverage its inherent mystery to create a profound sense of scale and awe, making players feel like true pioneers on the verge of a universe-altering discovery. It transforms from a background image into an experience, a challenge to be overcome and a mystery to be personally unraveled. This widespread cultural adoption speaks to a fundamental human need to find patterns and meaning, especially in the vast and often indifferent canvas of space. The hexagon is a pareidolia on a planetary scale. We look at it and see intention because its form is so familiar from our own constructs, honeycombs, nuts and bolts, architectural designs. This instinct to recognize and attribute design is what fuels the public's endless fascination. It sits perfectly at the intersection of known science and thrilling speculation, a real-world anomaly that gives us permission to dream. It proves that the universe is still capable of presenting us with breathtaking puzzles, ensuring that the wonder of exploration remains alive not just for astronauts and scientists, but for every one of us gazing up at the night sky and imagining what might be waiting at Saturn's pole. Even as we continue to analyze the treasure trove of data from the departed Cassini mission, the scientific quest to understand Saturn's hexagon is far from over. Earth-based observatories have taken up the mantle of constant vigilance, their powerful lenses trained on the ringed planet across vast distances. Advanced telescopes like Keck in Hawaii and the Very Large Telescope in Chile, equipped with sophisticated adaptive optics to cut through atmospheric blur, are monitoring the hexagon's long-term behavior. They track subtle shifts in its color, measure the consistency of its wind speeds, and watch for any signs of evolution across seasons, providing a crucial continuous dataset that spans beyond the lifetime of any single spacecraft mission. This persistent gaze from Earth ensures that even without a dedicated probe at Saturn, we are not blind to changes at its pole, maintaining a watch that might one day catch a crucial clue in the hexagon's enduring performance. The investigation also extends deep into the digital realm, where scientists are undertaking a monumental task, re-examining every byte of data Cassini ever sent back, but with new eyes and more powerful analytical tools. Machine learning algorithms are now being unleashed on these archives, sifting through millions of images and spectral readings to detect patterns and correlations that were invisible to human researchers a decade ago. This process is like giving the entire mission a second life, allowing us to ask new questions of old data. Researchers might train an AI to look for specific, faint chemical signatures along the hexagon's walls, or to create a three-dimensional heat map of the vortex with unprecedented resolution. This digital archaeology often yields profound discoveries, proving that the answers we seek may have been hiding in plain sight all along, waiting for the right technology to reveal them. While archival data is priceless, the ultimate key to unlocking this mystery will be delivered by future missions designed specifically to probe the atmospheres of the outer planets. Several exciting concepts are currently on the drawing boards at space agencies, each with the potential to revolutionize our understanding. One particularly promising proposal is for an orbiting spacecraft equipped with a much more powerful cloud-penetrating radar and a sophisticated atmospheric probe. Unlike Cassini, which gave us fleeting glimpses, a next-generation orbiter could spend years, even decades, focused intently on the polar dynamics, mapping the hexagon's structure in 3 dimensions over time, and through multiple seasonal changes to see how its engine responds to varying amounts of solar energy. The instruments on such a mission would be tailor-made for atmospheric dissection. A more advanced composite infrared spectrometer could map temperatures within the hexagon's jet stream and central vortex with meter-scale precision, identifying where energy is being added or lost. An ultraviolet imaging spectrograph with higher sensitivity could definitively chart the unique chemical compounds confined within the hexagon's walls, searching for anomalous particles that might point to unusual processes. But the real game changer would be a deep atmosphere probe designed to survive a plunge directly into the heart of the hexagon itself. As it descended through the layers, its sensors would directly measure wind shear, composition, pressure, and temperature, sending back a vertical profile of the phenomenon that would instantly validate or dismantle our current computer models. The dream mission for many scientists would be one capable of deploying a fleet of small, durable balloon-borne drones or mini-probes into the Saturnian system. Imagine dozens of these tiny weather stations drifting within the hexagon's powerful jet stream for months on end, creating a dynamic, moving network of sensors. They could directly measure the forces at play within the current itself, providing a real-time map of the energy flows that keep the structure locked in place. This kind of multi-point, in-situ measurement is the holy grail of fluid dynamics, offering a level of insight that remote sensing alone can never achieve. It would be like finally being able to dip our fingers into the water to feel the current, rather than just watching the river flow from a distant bank. Each of these proposed missions carries the promise of turning this captivating mystery into a cornerstone of planetary science, revealing not just the secret of the hexagon, but profound new truths about how all fluid worlds operate. This colossal, persistent structure offers us far more than just a beautiful mystery. It functions as a unique natural laboratory, a controlled experiment on a planetary scale that we could never hope to replicate here on Earth. The conditions within its six-sided walls provide an unparalleled testbed for the fundamental principles of fluid dynamics, meteorology, and planetary science. By striving to understand the precise mechanisms that generate and sustain the hexagon, we are effectively stress-testing our most advanced models of how fluids and gases behave under extreme conditions. The solutions we develop to explain this Saturnian phenomenon have the potential to unlock new chapters in physics, revealing universal truths about the behavior of rotating fluids that apply from the smallest laboratory beaker to the grandest galactic nebula. The implications for understanding our own planet's weather are particularly profound. Earth's atmosphere is a fantastically complex system, influenced by an uneven surface of mountains and oceans, which makes isolating specific physical processes incredibly difficult. Saturn's hexagon, by contrast, exists in a near-perfect fluid environment, free from the complicating factors of land masses. By studying how this massive standing wave maintains its energy and form, we can gain deeper insights into the fundamental nature of jet streams, Rossby waves, and polar vortices phenomena that directly influence weather patterns and extreme events on our own world. The hexagon acts as a simplified, magnified model, allowing us to observe in stark clarity the same core physics that governs the meandering path of our own jet stream, which dictates whether California faces drought or deluge, or whether a polar vortex will plunge the American Midwest into a deep freeze. Looking even further afield, the knowledge gleaned from this six-sided puzzle becomes a critical key for deciphering the atmospheres of worlds beyond our solar system. Astronomers are now discovering thousands of exoplanets, many of which are gas giants, so-called hot Jupiters or warm Neptunes orbiting distant stars. Our telescopes can only gather faint whispers of data from these far-off worlds, hints of their atmospheric composition, rough estimates of their temperature. To interpret this data accurately, we need robust models that can predict what weather patterns might look like on a gas giant with a certain mass, rotation speed, and orbital distance. Saturn's hexagon provides a crucial benchmark for these models. If we can successfully simulate the conditions that create and sustain such a precise geometric storm, our models will be vastly more reliable when applied to the exotic environments of exoplanets, helping us to virtually explore climates on worlds we may never directly visit. Ultimately, the greatest value of this natural laboratory may lie in its sheer defiance. It challenges our assumptions and pushes our computational capabilities to their absolute limits. Every time a new model fails to perfectly replicate the hexagon's stability or its startling depth, it forces scientists to re-examine their equations, to consider new variables, and to deepen their fundamental understanding. This process of being proven wrong by nature is how science truly advances. Whether the final answer is a refinement of existing wave theory or the discovery of a completely new atmospheric process, the journey to solve the hexagon is guaranteed to expand the frontiers of human knowledge, proving that sometimes the most valuable scientific tools are not the ones we build, but the ones the universe generously provides for us. So how do we navigate this fascinating tension between the rigorous science of atmospheric physics and the thrilling possibility of alien engineering? The key lies in understanding where the solid ground of evidence ends and the landscape of speculation begins, appreciating the value of both while recognizing their distinct roles in our quest for knowledge. On one side, we have a robust and testable scientific model that beautifully explains how a hexagon could self-assemble from the chaotic ingredients of a spinning gas giant. This explanation is powerful because it relies on known physics, it's supported by lab experiments, and it provides a clear roadmap for future research. It represents the scientific method at its best, observing a mystery, formulating a hypothesis based on established principles, and then seeking evidence to support or refute it. This process has unraveled countless cosmic puzzles before, from the nature of black holes to the birth of stars, and it demands our respect and serious consideration. Yet, the sheer perfection and longevity of the hexagon gently push at the boundaries of this natural explanation, inviting us to consider possibilities that currently lie beyond the fringe of conventional science. This is where speculation plays its vital role, not as a replacement for science, but as its imaginative partner. Speculation asks the what-if questions that can sometimes, though not always, point science in a new direction. It encourages us to think creatively about the limits of technology and the potential for life in the universe, concepts that are inherently wondrous and inspire public fascination with missions like Cassini in the first place. The line between the two is drawn at the requirement for testable evidence. Science must be able to make predictions that can be proven false. A good theory is falsifiable. The alien hypothesis, in its purest form, often struggles with this, as it can be adjusted to explain almost any observation, making it more of a philosophical stance than a scientific one. This doesn't mean we should dismiss speculative thinking outright. Instead, we can embrace it as a tool for expanding our perspective, all while maintaining a healthy skepticism. We can marvel at the notion of a planetary scale weather control system while simultaneously acknowledging that, for now, it remains a narrative without concrete proof. The most productive approach is to let these two modes of thought exist in a constructive dialogue. Let the scientific model be our baseline, our null hypothesis that we continually challenge with new data. And let the more speculative ideas serve as a reminder of how much we still have to learn, and of the breathtaking potential for discovery that still awaits us in the cosmos. This balanced perspective allows us to fully appreciate the hexagon for what it undoubtedly is, one of the most stunning and instructive natural wonders we've ever encountered, while keeping our minds open to the remote chance that it might also be something even more extraordinary. Now we turn this profound mystery over to you, because a puzzle of this scale deserves more than one perspective. After journeying through the science of standing waves and the possibilities of cosmic engineering, where does your intuition lead you? Do you find the laboratory models of rotating fluids and deep atmospheric dynamics to be a complete and satisfying explanation for this perfect, enduring hexagon? Or does your mind wander toward more extraordinary possibilities, that we might be witnessing the first faint signs of a technology so advanced it blends seamlessly into the environment of a gas giant? Perhaps you find yourself somewhere in between, captivated by the natural explanation but leaving the door open just a crack for a universe still full of surprises we can't yet imagine. We want to hear your voice in this conversation. Head down to the comments and share your personal theory. What aspect of the hexagon captures your imagination the most? Is it the impossible longevity, the thermal depth revealed by infrared scans, or that haunting, resonant hum that sounds so unlike any other natural phenomenon we've recorded? If you believe it's a natural masterpiece, what piece of evidence convinced you? And if you lean towards something more, what future discovery or observation would be your definitive proof? Your insights and questions are what make this community so vibrant, and they often shine a light on angles we haven't yet considered. This is more than just a debate, it's a shared exercise in curiosity. Your perspective is a vital part of the ongoing investigation. The most exciting chapters in our exploration of the cosmos are always written together. From its breathtaking scale to its hauntingly resonant hum, Saturn's hexagon stands as one of the most profound and beautiful puzzles our solar system has to offer. We've journeyed through the compelling science of rotating fluids and standing waves, a powerful natural explanation that reveals the universe's innate capacity for creating order from chaos. We've also dared to venture into the realm of speculation, considering the tantalizing, though unproven, possibility that such perfection might hint at technologies beyond our current understanding. Both paths lead to a sense of awe, reminding us that whether born from fundamental physics or unimaginable engineering, the hexagon is a testament to the incredible wonders that await our discovery. What makes this enigma so endlessly captivating is that it refuses to be neatly categorized. It is a permanent fixture in a dynamic atmosphere, a geometric shape etched into a swirling storm, a deep-rooted natural phenomenon that feels utterly artificial. It challenges our definitions and pushes the boundaries of our knowledge, serving as a powerful reminder that the cosmos is under no obligation to conform to our expectations. The true value of the hexagon may not lie in a single, definitive answer, but in the questions it forces us to ask about planetary science, the potential for life, and the very nature of reality itself. So the next time you find yourself beneath a clear night sky, take a moment to find that faint, golden speck in the constellation of Capricornus. Know that circling that distant point of light over 1 billion kilometers away, a perfect six-sided storm larger than our entire planet has been spinning in silent, majestic defiance for decades and perhaps for centuries. It is a beacon of the unknown, a cosmic whisper urging us to look deeper and wonder harder. Let it inspire you to embrace the mysteries that still surround us, to stay curious, and to never stop exploring the endless puzzles waiting to be solved, both in the vastness of space and in the uncharted territories of our own understanding. The greatest adventures in discovery are always